Okay, hello everyone. Welcome to our stream contest. Today's I will introduce you the refining of the oil. Okay, let's move into the first part. In the first part, I will introduce you the purpose of refining, and then at the second part, I will introduce you the classification of the refined. We can discard the refining according to the refining type, refining process, and the heating mode. And at the third part, I will introduce you some details of refinery. Okay, let's move into the first part. First part is about the purpose of refining. Refining meaning. After the refining of the oil, we will enhance the oil storage stability, because we know that in the crude oil there has more fatty fat acid. So after refining, we will remove the acid and then enhance the oil storage stability. And second, we can improve the oil flavor. The oil flavor. And the third, to improve the oil color. You can see that the crude oil is usually not clear, but you can see in the right picture. But you can see in the right picture, the oil is yellow and it is clear. So that is because we have completed the refining process. And first, we can provide the raw materials for oil and fat depot processing products, such as the soap. The soap we used is byproducts by the refining processing. Okay, let's move to the next part. It is about crude oil composition. Although the amount of these impurities is small in crude oil, but it plays an important role in affecting the quality and stability of the oil. There have some small impurities in the crude oil, such as the suspended impurities, such as sediment, powder, and cake residue. And the second is the moisture. The moisture will factor after the refining. We will adjust the moisture in the crude oil, and then you can store it refining oil for a long time. And the third is the quality of impurities. There are many patterns like phosphatides, proteins, sugars, and their lower breakdown. And then is the fat-soluble impurities, such as the free fatty acids, sterols, tacfurils, pigments, and fatty alcohols, waxes, and etc. And some other impurities, such as toxins, pesticides. Let's move to the next part. Next part is the refining process. Refining process, we usually have 4 parts. The first part is degumming, and the second part is the acidification. And the third part is decolorization. The fourth part is the odorization. You can see the this chart. First is the crude oil, and then is degumming. In the degumming part, we will add some hot water, and then we will separating the gums and the oil, and then we get the degummed oil, And then to next part. Next part is the acidification. In this part, we will add some alkali such as the NaOH to remove the acid in the oil. And in this part, after the sediments, we will get the soap stock as the byproducts. And then we get what? Get the neutralized oil. And then we move to the third part. The third part is decolorization. In the decolorization, we will add some white clay and some vacuum to remove the color in the oil. In this part, we will get the waste clay. The waste clay can be collected and then to recycle use. After decolorization, we will have the filter. Usually, we use the plate filter or the leaf filter to remove the waste clay, and then we get the bleached oil. Bleached oil then is the last part is deodorization. In the deodorization, we will move into the vacuum to get the deodorization oil, and then we get the refined oil. This is the whole process of the refining. Okay, let's move to the next part. This part I will introduce the details of the file parts and a description. This is suitable for our grease refining. In the first part is degumming, right? And in the degumming we will add 85% or 75% food grade phosphoric acid. And the amount of phosphoric acid it contains for 0.05% to 0.2% of the oil weight. And then is the deacidification. In the deacidification, we will add a certain concentration of a certain amount of NaOH to carry out acid-based the neutralization reaction, so as to achieve the purpose of removing free fatty acids in the oil. And then is the decoloration. In the decoloration, we will add 1 to 3% of the oil weight of the decolorizer, phosphical adsorption, and then filter equipment to separate the oil and the decolorizer, so as to achieve the purpose of decolorization. And then is the deodorization. After deodorization, we will improve the flavor of the oil. And this part at a high temperature of 220 to 260 Celsius and under a certain vacuum condition. A certain amount of superheated steam is injected into oil for stripping, and the purpose of deodorization is achieved according to different volatilization points of oil and the volatile small molecule substances. And the next part is the dewaxing. Usually, in the sunflower seed oil or the germ corn oil, there has wax in the crude oil, so it is not healthy for our body. So we must through the dewaxing process to remove it. And in the dewaxing, we usually by cooking, the wax and high melting point in the oil are particularly from the liquid oil, and the solid wax and the liquid oil are obtained after filtration. so as to achieve the purpose of dewaxing. Okay, next part. Next part is the classification of refining. This is very important. If you want to choose appropriate for your refining, you need to listen to this. Usually, we have three standards to classification of the refining. The first is about the type. The type is we have three types. One is the intermittent refining, and the semi-continuous refining, and then is continuous refining. This is usually classified by the capacity, such as let's look at the intermittent refining. If you want to use intermittent refining, your capacity is usually generally used for below or equal to 20 tons per day refining. It has more advantages, such as it is a simple and flexible operation. Investment for equipment is less suitable for a variety of oil changed frequently. This means that if you both have the sunflower seed oil and the germ corn oil or soybean oil, you can use the same equipment to process it, because it is suitable for a variety of oil changed frequently. You can change the oil, but it also have disadvantages, such as low oil yield and low work efficiency, and the product's quality is not stable. The product quality is more based on your operation. If your operation is not right, the oil quality will be low and greatly influenced by the operation. Yes, by the operation. And you can see in the picture is our equipment. Let's move to next part. This is the craft of our equipment. Here is the cooling water, and this is the thermal oil stove, and then is the this is the first part is the degumming, deacidification, decolorization, and deodorization. Okay, let's move to next part. And the second one is the semi-continuous refining. The capacity is generally used for 5 to 30 tons per day refining. The intermittent refining is below 20 or equal to 20 tons per day, but the semi-continuous refining capacity is 5 to 30 tons per day. That means that if your capacity is more than 20 tons per day, you may use the semi-continuous refining. And it also has some features, such as under normal circumstances, the front degumming and decolorization section is intermittent production, and the deacidification and deodorization sections are continuously produced by the deodorization tower process. And in the semi-continuous refining, we have the deodorization tower. But in the intermittent, we use the deodorization pot, not a tower, and other additional equipment to achieve continuous refining have more advantages, such as high efficiency and receiving economy, high additional output value. And their advantage and disadvantage between intermittent refining and semi-continuous refining. Okay, next part. Last is the continuous refining, and the capacity is generally for 30 or more than 30 tons per day refining. If your capacity is more than 30 tons per day, I recommend you use the continuous refining capacity. Continuous refining. They also have some advantages, such as the alkali refining section set disfigure, alternative refining port, neutral sedimentation separation. The continuous refining or section is continuously uninterrupted production. Advantage of this design is production consumption of small, low oil consumption, more stable quality of refined oil, and also has disadvantages. Disadvantage is that it is one-time investing big, but it is not suitable for frequent replacement of oil refining. Let's move to the last part. And unclassified by if you're classified by the refining process, popular water by alkali acid can distinguish between physical refining and chemical refining. You can see in the picture, in the chemical refining we will add some alkali, and then we'll get the soap stock. But in the phosphoric refining, we just use the tower. The deacidification and the deodorization is in the same part. And the chemical refining is universal for our oil, but the phosphoric refining is used for the colate content. High acid value oil it is less practical, such as the palm oil, palm kernel oil, and coconut oil. If your crude oil is palm kernel oil, and coconut oil, is more. I will recommend you use the physical refining. And according to the heating mode classification, we can divide into the thermal oil heating and the electric heating refining. And the electric heating refining is used for 500 kg to 2 tons per day. The feature is using resistance wire. Resistance wire to heat crude oil. The first investment is less, but the stability of the local voltage is required to be higher, and the power consumption is relatively large. The thermal oil reheating is more than 1 ton per day. If your capacity is more than 2 tons per day, I will recommend you the thermal oil heating, because the heating crude oil with the thermal oil requires a thermal oil furnace, but it is more economical in the long run. You can see the picture. The first picture, this picture is the thermal oil refining, and it is 2 tons per day. And in the right picture is electric heating refining. It is the 500 kilogram per day. And next part. There are some refining details. In the degumming, the process of removing glycerol impurities from whole oil is called degumming. The method we use in actual production is special wet degumming, which is one of the hydraulic degumming methods. And the basic principle of wet degumming is to use the hydrophilicity of phosphoric phase and other glycine soluble impurities to add a certain amount of electrolytic solution to oil, so that the colloidal impurities absorb water, condense, and separate from the oil. Among them, phosphoripates are the main ones. And the insoluble impurities not only affect the stability of oil, but also affect the technological effect of oil refining and deep processing. In the process of alkali refining, grease will promote emulsification, increase operation difficulties, increase the consumption of refining and auxiliary agents, and reduce the quality of soap feed. In the decolorization process, the absorbent consumption was increased and the decolorization effect was reduced. And some factors will affect the degumming, such as the yield of the water and the operating temperature, the mixing strength and the action time, and the electrolyte. And then is the deacidification. Deacidification. There is always a certain amount of free fatty acids in vegetable oils, and the amount depends on the quality of the oil. The impurity of seeds and the high breakage of oil seeds are the reasons for the high acid value of oil, especially under the condition of high moisture, which is very unfavorable to the preservation of oil, which will increase the free acid content, reduce the quality of oil, and worsen the edible oil quality of oil. The main methods of acid removal are alkali refining and distillation. Let's to some factors to affect the alkali refining, such as the alkali and its dosage, and alkali concentration, the melting of ley, the operating temperature, the operation time, mixing and stirring, impurity, separating effect, and the washing and drying. These are all the factors affecting the alkali refining. And then is the decoloration. The pigment compounds in vegetable oil are complex, mainly including chlorophyll, carotene, flavonoid pigments, iodine, and some carb and protein decomposition products. Oil decolorization is commonly used by adsorption and decolorization. The principle of the adsorption colorization method is to use the absorbent with strong adsorption power to absorb pigments and other impurities in hot oil, and to remove the absorbent pigments and the impurities while filtering the absorbent so as to achieve the purpose of decolorization and purification. And there have the types of the absorbs. If you want to use the this is some types of the absorbent. If you want to start your refining project, you need to buy the absorbents first. The first type is the bleaching clay. Bentonite is a kind of natural absorbent, mostly white or off-white. The deodorization confidence of natural bleaching soil is low. The decolorization ability of is poor, and the oil absorption rate is also large. And then is a chipped clay. This is a kind of absorbent with high activity, which is made from bentonite by artificial chemical treatment, and it's widely used in industry. It has strong absorption capacity for pigments and colloidal substances, especially for some basic aromatic groups or polar groups. The activated clay is the most recommended. And then is the activated carbon. The activated carbon is made of oat chips or basic rice husks, hard fruit husks, and other substances through chemical or physical activation. It has low pores, large specification surface area, high decolorization coefficient, and has hydrophobicity, which can absorb polymer materials. However, the price is expensive. The oil absorption rate is high, and it is often mixed with bleaching soil or active clay. Let's move to the next one. There are some factors affecting the absorption of the decolorization, such as the absorbents. Different absorbents have different characteristics, and the appropriate absorbents should be selected according to actual requirements. Oil decolorization generally uses white soil with high activity, low oil absorption rate, and fast filtration speed. And second is operating pressure. The third one is the operating temperature. The operating temperature of the absorption decolorization depends on the type of the oil, the operating pressure, and the type and the characteristics of the absorbents. The commonly used deodorization temperature is about 105 Celsius. And then is the operating time. The contact time between the oil and the absorbent at the highest temperature in the absorption decolorization operation is determined by the absorption balance between the absorbent and the pigment. And the decolorization temperature is generally controlled in the industry at about 20 to 30 minutes. And the fifth factor is stir. In the decolorization process, the adsorption of pigment by the absorbents is carried out on the surface of the absorbents, which belongs to the heterogeneous phosphate chemical reaction. Good agitation can make the grease and the adsorbents have a uniform contact opportunity. Direct steam stirring is used in production. And the last one is the crude oil quality and the pre-treatment. Let's look at the video. I will introduce you a video for our intermittent refining. Okay, this is the 1 to 20 tons per day batch type edible oil refining plant. The whole plant is designed by our engineering. You can see that in the first of our, we place a cooling water tower outside the workshop. The water jet, you can see cooling water tower and the water jet deep space pump in the outside. The main equipment of the intermittent refining workshop is the alkylase melting pot, the colorization pot, steam generator, plate filter, thermal oil furnace, and so on. And this part is the heat transfer oil system. The transfer oil furnace. Furnace next to is the high tank and the lower tank. This is the high tank. This is the lower tank. The lower tank is used to store heat transfer oil. Connected to the high tank, there is a gas liquid separator, and used to remove the heat transfer oil, water, and air. The high tank. The heat transfer oil is the high tank there is a gas liquid separated tank, and to remove the heat transfer oil, water, and air. The high tank is used to store the separated heat transfer oil, water, and air. To avoid heat transfer oil containing too much water and air affect the heating effect. And then the heat transfer oil. This is the separator liquid separator. And then the transfer oil is then piped to each section of the inter-refining plant to provide heat sources for the inter-refining processes. The heat transfer oil is recycled throughout the workshop. You can see that is the whole refining. Yes, the heat transfer oil is cycled throughout the workshop. The heat transfer oil, the temperature will is heated to about 260 to 300 degrees through the heat transfer oil furnace. This is the furnace to provide a heat source for the workshop. The use of the thermal oil heating has the advantages of high heating efficiency and low cost. The crude oil will pumped into the first pot to let into the first